week 2. Did you complete week 1?
Yes, sir.
So did you solve the problem that given from the vector chapter from your
Sir,
reference
I have
books?
solved some of the problems.
Then what about others?
Sir, I will do that.
Yeah, so that's why we are delaying to deploy the second week.
Okay, sir.
Can you see my screen, right?
Yes, sir.
All right. So in the previous class, basically we discussed about that coordinate system, basically the polar coordinate, and we also talk about that vector component, how to resolve a vector in the two-dimensional and the three-dimensional case, and how to represent a vector from different coordinate system like the polar coordinate system. By the same analogy, you can also able to do that extended idea for other coordinate system like cylindrical and also the polar coordinate system. All right, so today I'm going to talk about basically the multiplication of the vector. So how we are going to find out that multiplication. So say multiplication of the vector that we can do that in the two-way, right? Vectors. So one we define is a dot product or scalar product, or sometimes we define this called actually inner product. Inner product. Second method we define that's called cross product or vector product, or sometimes we also call this is actually the outer product. These two keywords actually, the inner product and the outer product, basically we use in our quantum mechanics language. So it's the same thing, which is actually the dot product and the cross product. This dot product we find out in the two-way. Say this is dot product. Say I have two arbitrary vector in Cartesian coordinate system, which is ax I hat plus ay z hat plus az k hat, and the vector b would be bx I hat plus by z hat plus bz k hat. So this is the two arbitrary vector in Cartesian coordinate system where ax, ay, and az basically the component of that vector in the x, y, and z axis, and also for that b and izk actually the unit vector in the direction of x and y and z axis respectively. Now uh, the dot product of this vector we can find out. Say one way actually we can write a dot b, right, which would be basically ax bx plus ay by plus az bz, right? So this is the formula, you know. So but this formula come basically what we are going to do, we are going to basically multiply that vector with that one. I multiply this component of vector A with the rest of the component vector b. So in that case, ax bx I dot I plus ax by I dot j plus ax bz I dot k. I know that there's I dot I actually the 1, but I dot j and I dot k would be basically that 0. So which is actually I talk about said that similar identities will be survive, which means that I dot I actually the 1, but I dot j, which is dissimilar identity, will be vanished. So that's why we neglect that part. Similarly, that's why we write ax bx I dot I, ay by z dot z, and az bz k dot k. They will be survive. Rest of the term will be basically the vanish. That's how actually we can find out that dot product of these two vector. Second method we can use, say we write this is a dot b actually ab cosine theta, right? Where a and b actually the magnitude of vector and theta is the angle between that two vector. So this is say the vector a, and say this is the vector b. Should use the vector sign over here. Then this is would be the angle between these two vectors. Then we can use that formula. If I just know the angle and the vector as well, then I can use that formula. And if you just know the vector, then you can use that formula to find out the dot product of these two vector. And remember this from here, we know that we take the component of that vector, one vector towards in other direction. So this is the vector A, and this is the vector v. If it is create the angle over here theta, then I can say this is actually the a cosine theta, right? And this is actually that b cosine theta. From here you can say that a cosine theta, or vice versa. You can say this is would be actually that b cosine theta, which is the component of vector in the direction of vector a, right? So it means that b cosine theta over here is the component of vector b in the direction of a. I can write in two way this thing actually. A dot b actually a b cosine theta. I can write one is this b cosine theta, or I can also write down a cosine theta into the b. It's giving me the same thing. Now, b cosine theta actually the component of vector b in the direction of vector a, and a cosine theta is the component of vector a in the direction of vector b, right? You understand? So this is
Yes,
actually
sir.
the you can say the physical significance of this dot product. We're getting this to dot product, and we'll find out some vector which is one vector in some towards direction. Then another part actually the a cosine theta or b cosine theta is the component of the second vector in the direction of the first vector. That is actually you can say in that way. And since uh, this vector, I should say one more thing over here. Say if that a cosine theta actually the component of vector a in the direction of vector b, then I can say another thing actually that component would be a sine theta, right? Because this angle is theta, this angle is 90, then definitely this angle is going to be the 90 minus theta, and cos of 90 minus theta actually that sine theta. That's why this a sine theta is the component of vector b in the perpendicular direction of vector a. Sorry, vector b. A cosine theta is the component of vector a in the perpendicular direction of vector b, because this is actually the perpendicular direction of vector b. A cosine theta actually the component of vector a in the direction of vector b, but a sine theta is the component of vector a in the perpendicular direction of vector b. That's how actually you can interpret this component over here. But the same analogy, you can say this one would be, this component would be basically that b sine theta, which is actually the component of vector b in the perpendicular direction of vector a. All right. Now, since this dot product is a scalar quantity, that's why its value could be greater than 0, it could be equal to 0, and it could be also the less than 0. The theta would be greater than 0, or means it's the positive if your theta is greater than 0 and less than 90. It would be equal to the 0 if theta equal to 90, and it would be less than 0, so that's mean the negative if theta is greater than 90 and less than 3 pi by 2, so that's mean the 270 degree. Then the value of this two dot product is going to be negative.
Sir, isn't the theta from pi by 2 to pi?
Pi by 2 to,
Pi.
so that's when you are, so it should be same actually, so that would be the repeated version. So if you're saying pi by 2, that's been 92 pi,
Yes,
that's
sir.
one. For
Yes,
which
sir.
condition?
No, we use from 0 to pi. We use cos theta from 0 to pi range.
Cos theta. So I'm talking about the component of this one actually. It
Oh,
doesn't depend on that cos theta or sin theta. It's depend on the component in which axis actually. Then you will find out.
oh, okay.
All right. So now let's talk about actually that. Uh, and there are some properties of this dot product. We can say that a dot product actually basically symmetric. Symmetric means we can write a dot b must be equal to b dot a, right? So it doesn't care about whether you multiply five. Sorry, it's not a cross. I'm making a mistake. Use this thing over here because it's a vector and a scalar quantity. So if you write 5.2, that would be also 2.5. It's the same thing, right? So the product would be basically the 10. And we can, there are other some properties actually. Say we can write if you have some, say that this scalar quantity, we multiply by this vector a, and we take this thing, we can write n is another integer, another, you can say that m and n basically they are real number set. We define in general case in that way. So this is the vector a, where we write m and n actually the set of the real number. That's actually the procedure, how we can find out this thing. And uh, one more thing actually, we say if you have three vector, it's called the vector triple product. uh, Say I have three vector a, b, and c. If I take, say in that way, say first I take is cross product. It's basically the vector, right? Because c is a cross product, it's a vector. With that vector, if I multiply or take the dot product with vector a, whatever I will find, it would be basically the scalar quantity, because end of they say basically the dot product. Then if I write the another way, say that a cross b into c, or if I write b dot a cross c, it will be the same, because at the end of case all are the scalar quantity, it will be the remain same, it's not going to change. This is not actually the vector triple product, because it's basically the scalar quantity. So whatever the permutation condition you apply over here is going to be the same over here. Let's talk about vector product, or means
Sir,
cross product. Yeah.
is A dot B dot C valid? A dot
A,
B dot C.
A dot.
B dot C.
Yeah, you can do that because it's basically that. No, 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 no. That's not valid because A dot B, that will be a scalar
Scalar count.
scalar quantity. With that scalar quantity, we cannot take again that another dot product actually.
Oh, okay.
You're talking about the dot product, all our dot product. Right. Let's think about that vector product. It's a vector product if we use the same two vectors, say that we write down is arbitrary, say that ax I hat plus bx j hat. Sorry, it's not bx, it will be that. This one. It should be ay j hat plus az k hat, right? Say that vector b I write, say bx I hat plus by j hat plus bz k hat. Now this cross product or the vector product also we can find out using the two methods. The first method we are familiar with, that's called actually that determinant method, which we represent the component or the coefficient of that vector. We write, say that ax, ay, and the az, right? And this is bx, by, and bz. I just write down that component of this vector along to that direction. This is all the component in the x direction, and this is all the component for the y direction, and this is for the z direction. Now, what we write for this, the determinant process, actually, I'll first take the x coefficient. When I write, then I'll write actually ay bz minus az by, right? Plus, I'll use the plus. There is a issue over here. Instead of using the minus sign, there you will sometimes find out the minus sign also over here. I'm coming to that point. When I'm writing, it will be az bx minus ax bz plus the k hat. It will be ax by minus ay bx. This is the case actually. This is the formula, and I'm not going to recommend it you to guys memorize these things. If you memorize, definitely you are going to make a mistake over here. But there is a way I carry this information in my head actually. If you want, you can follow that one. What I did, I write that component over here, say in that way, x, y, z. So when I'm going to find out, say that x component, this one, I start from that y. I'll write down the y component of the first vector into z component of the second vector. So that's when I'm moving from ay bz minus az by, right? There is a minus sign because when I'm writing ay bz, I'm moving the counterclockwise direction. So that's why I use the positive sign, because that's the convention. When you're moving from the counterclockwise direction, it will be positive for the vector or the angle, or the coefficient. And when you're moving to the clockwise direction, it would be the negative, right? So that's why I write down az by is a minus sign. Fine. So when I'm writing that y component, so that's mean the z component, then I'll write down this one is z bx minus ax bz. And the third one, when you're taking the z component, I will start from ax by minus ay bx. It's a back and forth relation actually. When I'm moving to the counterclockwise direction, I will take all the positive. When I write down the clockwise direction, all the component will be basically the negative. And sometimes you will find out that there is a minus sign instead of over here. If you use the minus sign, then this thing is going to be the reverse. This will be the plus and this will be the minus sign over here. So if you want, you can use in that way, but never try to memorize these things because most of the case you guys make a mistake over here to find out this cross product using this method actually, but which should be basically the unfair because you are learning these things from your school life. Still, if you make a mistake to doing this calculation, definitely it should be unfair. All right, the second method we use, say, which is actually that a cross b is going to be that AB sine theta into theta hat, right? So this is actually that. If I know the angle, then I can use this one to find out that cross product of these two vectors. But remember, you have to know that the angle between the vector actually A and B in between. And this eta hat must be perpendicular on both A and B separately. So it doesn't require that the A and B will be mutually perpendicular each other, but this eta hat must be the perpendicular on both A and B separately. So if the angle is theta over here, then the eta hat would be towards that direction. If you write down the A cross B, or if you write down the B cross A, then it would be towards that downward direction in the negative eta hat direction. And to find out that direction, actually, you have to use that right hand rule, right? You know how to use that right hand rule. You have to put your forefinger or the index finger in the direction of the first vector, and you have to place your palm towards the direction of the second vector. If you place in that way, after that, you have to rotate all of the finger from first vector to the second vector. If you do that, then your thumb will give you the direction of the resultant or that eta hat direction. So that's why if you place your forefinger or the index finger in the direction of that, and if you put your palm towards that direction, which is the second vector, if you rotate from first vector to the second vector, your thumb would be towards upward direction. So that's why eta hat would be over here, upward direction. But if you place the forefinger or the index finger toward that direction and palm is toward that direction in the second vector, then your thumb would be downward direction. You can check that one by yourself. So that's how actually we can find out this direction of the eta hat. And remember, this is also would be the direction of the resultant vector because this is A cross B, actually the vector, it has some direction, and the direction would be basically in the direction of that eta hat. So that's why this eta hat, you have to find out in that way. It is important to find out the direction. Unless you do not find out that direction properly, this is not going to be a vector, right? Vector has some direction. If you only find out the magnitude, that's going to be the scalar quantity. And most of the case, if you want to find out the angle between the two vector, try to use the dot product. Never use the cross product because this cross product will sometime will not going to give you the exact result if you cannot find out the proper direction of this eta hat actually. So that's why it is better to choose the dot product. Dot product always give you that accurate result to find out the angle between the two vector. And say this one is range. We can also find out if you want to find out say the where it will be positive, this we can say the A cross B will be positive in the range is if the theta is greater than 0 and less than pi, will be equal to the 0 if theta is basically 0 or n pi, and basically this is not or, and it would be less than 0 if theta is greater than pi but less than twice pi. that region it would be basically the negative. There are some properties of this cross product also, which we can say this cross product is not symmetric. So that's mean you cannot write say that A cross B not going to be basically a B cross A, right? Why? Basically the direction of the A cross B is the opposite of the direction of B cross A. You can write equal. In that case actually you have to flip the direction using minus sign in front of A, then it could be the equal, otherwise not. So that's why you say that A cross B or the vector product is basically anti-symmetric. It's not symmetric. And this is also true, say this one, say that if I write then A cross B cross C is not going to be equal to A cross B cross into C, cannot be same because its direction will be the different, right? So that's why it's not equal like that. The dot product is same. And what is the significance? You can say that if we talk about the cross product, physical significance of this thing, A cross B, say you have a two vector, or I can say in another way, say that this is actually the length and the breadth of your room. So this is that your room. Say the floor basically. This is I draw over here. And if you take um, length into breadth, and you take that way, say if you take that A cross B, what it will give you? Can you tell me? See, if you take the cross product, one length of length and the breadth of your room, what it will give you physically? Did you get my question? Hello?
Sir,
Can you the question? Hmm? What it will give you? If you take the length and the breadth of your room, of the floor, then what it will give you basically? You take the
the
cross
area.
area, right? So that's mean you'll find out basically that area. And remember, this area is a vector. So that's why when you write down that formula of the area, always you will see that they write in that way. Length, they use this symbol into breadth, right? They never use that dot symbol over here because it's a vector. Area is a vector. Remember this thing, and it has the direction also. Then what will be the direction of that one? Direction, it would be perpendicular to that surface. Either it could be upward or it could be towards the downward direction. The area vector will be always perpendicular to that surface, whatever you are calculating that one. So that is actually the physical significance of that A cross B. So you are going to get that if you take the cross product of the two vector, basically is giving that area of that surface. And the previous case, I say you say if you think another way, say this is that actually your room. If you take in that way, so this is actually the one vector A, another vector B. This is that vector. This is say A vector, and say this is actually that C vector. Now, if you find out, say that A dot B cross C, what it will give him?
So the area, I guess, or
Hmm. Area, the total product of this one. If you multiply, say, B cross C is area, right? Because I said that one. If you take the cross product, that will give you the area. With respect to that area, if you multiply one more length, what it will give you?
the volume.
The volume, area into height, right? That will give you basically the volume, which is basically that scalar quantity. And that's why the volume of a room will be the same. It doesn't care about if you take that A cross B dot C, what you will find if you take that A dot B cross C or C cross A dot B, that will give you the same thing, which is that volume, which is the scalar quantity. It will be remain same. So that's why I write down that in the case of the dot product, these three combination will be that same. It is going to represent basically the volume of that something if you represent by that three vector. That's actually the physical significance of this dot and the cross product. You should know this one because when you are doing something, actually what actually indicating, you should know this one. All right, say somehow, say if you want to find out, say that instead of dot product, this call actually that vector triple product B cross C, how we are going to find out for that. If it is B cross A, that's going to be easier, right? We can find out using that A B sine theta or determinant process. With respect to that vector, you have to take again actually another mm, cross product. So that's when you have to perform two determinant process. That way you can find out, or you can use that second method. But in that case, it would be difficult to find out unless you cannot find out the direction of the resultant vector eta head. It would be tough for you. Either you have to use the determinant process, which is with the lengthy process. That's mean two times you have to do that operation. Or there is another method we talk about, is called actually the backup rule, actually the shortcut method we can use. Say this is B vector. If I write AC or C into minus C into A dot B. So it's in a short form we define actually is called that back. If I write them later side by side BAC, and this is will be that cap backup rule. Or you can use another method actually. It's called the number method. I use also that one, 2, 3. If I label the first vector by the 1, second vector by the 2, third vector by the 3, then the first component would be 2 on 3, and the minus it would be 3, 1, 2. Why I'm write down this thing, because sometimes it will be the case. Say I have to write, say that the D cross E cross F, right? Then it's difficult to that one to use the back cap rule because the letter was different over here. Letter is different, so that's why easily I can write the. It would be the 1, 2, 3. It would be the 2 on 3. 2 is basically that E. 1 is D into F minus 3, 1, 2. 3 is F. 1 is D. 2 is E. Right. So that's how actually we can take that cross product of three vector or more than three vector. We can also do in that way. Say if you find out somehow, say that you have the four vector, we are taking A cross B uh, cross C cross D, right? Or you can use the parentheses, then it will be easier. What you can do, actually you can consider this vector a single vector. Say I use this on another vector actually, that E, then C cross D, right? Now I can use again that backup rule actually, that 1, 2, 3. If you actually that 2 on 3, 2 on 3 would be C E dot D. 2 on 3 minus 3 on 2. 3 would be d e dot, let me check, 1213 and 312 to 2 will be basically the C over there, right? So that's how actually we can find out that cross product more than 2, 3 or 4 vector. That way you can find out that multiplication of that vector.
Sir, I have a question.
Yeah, sure.
Sir, you are not using any dot sign or cross sign on right hand side before fast bracket. Is it the cross product, sir?
This is the cross product, yeah, over here. This one talking about, this
No,
one,
sir. I'm talking about the right hand side before
right hand side.
fast.
Oh, this one. Yeah, so that's actually the symbol. It's a multiplication actually.
Okay, sir.
Because look at this, I got your point actually. So since it's a vector, right, there is no symbol I'm using over here, right? Over here you're
Yes, sir.
talking about. So what is that? E dot D is a vector or a scalar?
It's a
Yes, sir. It
scalar.
is.
It's a
Scalar.
scalar quantity. It's a multiplication with that one. The properties I said over here, look at this. That one is a m into a and n into b, where m and n, I say the scalar quantity is a set of real number.
Yes, sir.
You'll find out basically this will give you some number over here, either positive or the negative number. So that's when you have
Okay,
to
sir.
multiply that thing with that rest of the thing of that vector.
Sir, I have a question.
Sure.
Sir, in this method, if the left hand side are and the right hand side is the same,
Of course.
um, so if we do the cross product on the left hand side,
Mhm.
for any cross product, we will get a vector. Okay.
It's a vector. You're talking about, so left hand side is a vector, right?
Yes, left hand side is vector, but the
Yeah.
right hand side may not be a vector, I think.
May not be a vector. I got your point actually. Look at this. So E dot D, what it will give you?
A scalar.
A scalar, say a number. I got the 3, right?
Okay.
So if I multiply 3 with C, what will be that? V scalar or a vector?
That will be a vector, I guess.
Definitely vector. You're
Yes.
multiplying with the vector with the scalar quantity. And minus, say it will be, say that the 2D will be a vector or a scalar.
Vector.
It will be vector. Then the left hand side is also the vector.
Okay, sir, I got it.
Yeah. All right. Is there any more question over here? No question. All right. Say let's do a problem. Say I draw a cube over here. To think about, although my drawing is not exact, but try to think about it in that way. Right. Say it's cube basically, and I draw two diagonal. It's called the face diagonal. One diagonal into that face. Are you familiar with the diagonal, right?
Yes, sir.
So I draw two diagonal, say diagonal, face diagonal actually. I should write, say this is that, and I also represent by a vector. Say this is a vector and this is the v vector. And should I? No, it doesn't require. Now I want to know that what would be the angle between these two vectors. So, or you can think in that way. So you are in a room. So you have that six face in that room, right? So think about one face a diagonal vector into in one wall, and another wall which is consecutive wall which is connected to that wall. You draw another vector into that face diagonal actually. Now I want to find out the angle between these two vectors. Can you predict what would be that angle? So that's been this diagonal actually into that face, and this b vector actually into that face, and they are perpendicular over here, right? These two face actually perpendicular over here. Now my question is, what will be the angle between these two vectors? Can anyone say me that angle or can predict?
Sir, it might be 90 degrees.
It might be 90-degree. All right. Is there any more answer? Say, uh, I level that there is pi axis. Say this is x axis, y axis, and say that is actually the z axis. Fine. Say
Sorry, it will be 90 degrees. Right?
it will be 90-degree. All right. Let's check that one. Say to find out that angle between these two vector, I will use that formula because I say that when I'm going to find out the angle, I will always use this formula a dot b actually, that ab cosine theta. This is very useful and very handy to find out the angle between two any vector. All right. To find out, then I have to know that of this vector, right? I have to represent that vector. Say, I know the all of the side a's or the length of this cube are equal, right? So if it is say that the one side actually that a, then all of the side would be that a. Then, can you tell me what would be that coordinate of that point? Say this is a level by the P, and say this is a level by the point Q. What would be the coordinate of that point P? Hmm?
Sir, XZ.
XZ? XZ, yeah. Can you say in term of basically that A?
So is that a cube? I mean, depends
It's
on.
a Q, definitely.
Then it will be a comma a.
A comma A?
I mean that.
Oh, sir, I didn't notice the A.
All right, so or you can use anything actually. Say if it is that a, I give you the a, you can consider any other number actually because that is a q, so the length would be that same, right? Then
Yes.
definitely to locate that point p, I should write it would be a, 0, and a. It's a three-dimensional. If you say only a and a, that's going to be the two-dimensional.
Oh, so
Yes,
We are
sir.
dealing with right now the three-dimensional. Now what about the q? What will be the q?
So 0, comma a, comma a.
0, comma a, comma a. Exactly. Right. So you just if I know that point, then I can find out basically this vector a. It would be a I hat plus 0 z hat plus a k hat. Right. Ultimately, I will find out basically this vector would be a I hat plus a k hat. By the same analogy, I can write down the vector b would be a z hat plus a k hat, right? Then I can find out what would be the magnitude of this a. It would be basically a root 2 right? A square plus a square, that's going to be 2a square. If you take the square root, I'll find out that a root 2. The same analogy, I can find out the magnitude of the b would be also a root 2, right? Am I right?
Yes, sir.
All right, now I'm going to take that, say that the dot product of these two are a dot b. I'll write them side by side. Aj plus ak.
পাগল তুই কি পাগল ধ্যাৎ, তুই সরেন তুই সর
Please mute your
তুই কি ফাইজলামি
microphone.
করবি
All right, so the b would be, sorry, I write down that b first, so I'm sorry. It doesn't care, it's a dot product. It's not a big deal. I can change the orientation since it's a dot product. Then it would be aj plus ak, right? Look at this, I reverse that direction. I write down the a over there, a vector actually ai ak, but I write down the a z ak, which is the b, because it's same, a dot b equal to b dot a. It's going to be the same. All right, now look at this. This one would be z. God, I write down the double of I. Make mistake, it would be the I over there. I'm sorry. It would be a I over there. Now, if I multiply this a j with the ai, that would be basically the zero, right? A square j dot I write it for you. A square j dot k plus a square k dot I plus a square k dot k. These similar identities, j dot I, j dot k, and k dot I is going to be the vanish, because this is basically that 0. But k dot k actually that 1. So I'll find out the a square over here. Now I'm going to use that formula, a dot b actually that ab cosine theta. I'm just to find out the theta. It would be cos inverse a dot b divided by magnitude of a and the magnitude of b, which will give me actually that cos theta. A dot b actually that a square, right? And magnitude of a and the b, a root 2, which will give you actually a square 2, right? A root 2 would be a square into 2. That's why this a square we cancel out. You'll find out cos inverse half. What is the value of the cos inverse half?
60.
It's a 60 degree. That's mean the angle between that two face diagonal will be 60 degree. Although the plane are perpendicular to each other, but they are not 90 degree. They're 60 degree face diagonal. Okay, and now if I ask you, can you find out, say that the body diagonal? Say if I ask you, that angle you can also find out. Say if I want to ask you, find out that it's create an angle over here, that vector create with the x-axis or z-axis or the y-axis. You can also find out that one. How am I going to find out that one? You can also find out that thing also using a dot b actually a b cosine theta. Then in that case you have to consider a vector towards this direction, right? You can find out that length. What would be that angle? Can you predict this one? The vector a going to create the angle with that x-axis. How much angle vector a will create with the x-axis? Now make a guess. Your guess is going to be the right this time, I think. Let's try at least.
Sir, 60.
60 degree again?
I'm just guessing.
We're guessing. Is there any more guess? Or any different
So
result?
45.
60 or 30, anyone.
60 or 30, that's going to the combined 90-degree, right? It's a safe zone to say in that way. Someone want to say the different answer
So 45.
is 45. It's 45-degree, definitely, because you can find out this one. This this is actually going to be that point. You can check that way. It will be 45. I do not know. Let's check that. It could be. To find out basically that one, I need to check these two vector, which is vector A. Vector A is basically what I write. It's a I hat plus a k hat, and another vector I have to take in that direction that I know, which is actually say I write another vector is the B, which is I can write a I hat, right? I'm taking actually with that x-axis, although they didn't give me any vector, or I can choose that I vector, or simply the I, because I if you take that unit length actually, so then what will the case? Magnitude of A is a root 2, magnitude of B is basically only that A, right? What about A dot B? A dot B would be basically A square, because I dot I1, but I dot K is basically the 0. Now plug it into that cos inverse A dot B A square divided by A square root 2, which is 1 over root 2, which is definitely going to the 45-degree. Did you get my point? Let's find out the angle with that y-axis. What will be that one? This angle. Now, can you make a guess that one? Do by
So
yourself. The process.
75 degree.
How much?
So 75 degree.
75-degree. I'm not sure about that one. I have to calculate that one. Did
Which
you
one,
do
sir?
that? That angle from vector A is going to be create with that y-axis. This one. It's a three-dimensional. I do not know. You can calculate that one basically.
180 plus 45 degree.
180 plus 45 degree. I'm not sure. I have to calculate. Why are you saying that that's 180? Why are you saying that this is 180 degree? No, no, no. I'm not sure. I cannot visualize that one. I have to calculate that one. Just take the vector actually, because let's check that whether what it's become, because my vector A actually sorry a I hat plus a k hat, right? It's not me. This is a vector A, right? A I hat plus a k hat, and a vector y would be the z. Uh, Vector y is going to be basically vector, say that b will be a z hat. It's not going to create an angle, because a dot b basically is going to be that 0, right?
Yes, sir.
It's going to create a 0. Then cos 90. But the angle is 90 in that case. It's a 90-degree. Because that two plane actually the perpendicular to each other right now over here. This angle, look at this. That plane actually right now is create angle over here. It's very difficult to draw. It's a 90-degree, that's fine. This angle, or I cannot draw that one over here. It's a 90-degree, definitely. If you draw this angle, Did you get that one? So if I draw that plane, is this one. This angle is it's the inclined plane actually passing through that edge actually. If you consider a plane from this one is that plane actually, which is definitely the 90 degree of that angle. So that's mean this a vector create a angle 90 degree with that direction with the y-axis 90 degree over here. All right, so that's the procedure actually to find out the angle with different axes. Using that way, you can find out that angle. All right, let's do another case actually. So this is a case actually where a plane is landing. When it's landing, there are four forces actually acting on this plane when it's descending. Now we want to find out that resultant force acting on that plane during this plane is descending or landing. For a safe landing, what would be the direction and the magnitude of the net force on that plane? This four force is given actually. Now we have to find out that resultant force acting on that plane. Now can you make a guess? Just make a guess. What would be the direction? Only the direction, the resultant force on this plane. Can anyone make a guess over here? Just make a guess. Let's check that whether your idea going to do work or not. Hmm? Can anyone say that one? Or even think in another way. When a plane actually the land, not for this one, what is the resultant force actually acting on the plane when it's descending or when it's landing actually? Or can you say, I draw a quadrant over here. There are four quadrants, right? First, second, third, and the fourth quadrant. Which quadrant it would be the direction of the resultant force for a
The
safe landing of a plane?
the horizontal
Aeroplane.
quadrant, I think, at the x-axis, I think.
X-axis?
Sir, in the
X-axis.
second quadrant, sir.
The
So I
second
what's a
quadrant.
quadrant?
So this is say that x-axis, this is the positive y. So this is the negative x, and this is the negative y. Which axis it would be? Second x. Second
It might
quadrant.
be.
It might be. All right. So it might be. Is there any more answer?
Sir,
Someone?
fourth.
Fourth quadrant. So fourth quadrant. The resultant direction of 2. That's all. What about others? If you do not say any answer, I will say that you are thinking about that. The plane will never land. Are you thinking in that way?
Sir, I think second quadrant.
That's good. Second quadrant. Someone say first and the third quadrant. Then all the four possibility will be covered. Someone will be the get the right answer. All right. Look at this. If you say in the second quadrant, then there must be some component of the force would be that direction, and some force would be towards that direction. Then it could be that second quadrant, right? Do you understand that point? If you say the resultant force in the second quadrant, then the component of the force must be negative x and the negative y. All right, this one I can accept, but this one I cannot expect that one. If it is act in the positive y direction, then plane cannot be land downward direction. When plane is landing, the gravitational force actually acting on that downward direction, because that one actually responsible to descending the plane in the vertical direction, right? That's when is basically the decreasing is height step by step. So that's why it's not a valid reason in the second quadrant. It's also true for the first quadrant. If you say the first quadrant, that is also not valid, right? What about the fourth quadrant? If you say the fourth quadrant, all right, so then gravitational force is acting on that one. That's fine. That's going to work for you, which is descending the plane. But if the net force, one component is towards that positive x direction, then there could be the resultant direction would be in the fourth quadrant, right? Because it's a basically the vector triangle law, or you know that if you have a two vector, you know another way. If you have two vector in the two different direction, then the resultant would be in between that two vector. Using that idea, I'm saying the reverse way. This is the resultant vector, then definitely the component will be toward that direction. But problem is that if it is in fourth quadrant, if the resultant vector x component is towards in the positive direction and the y component is the downward direction, that's fine. But this cannot be. If it is, the plane is going to be skied from the runway. It cannot make a safe landing. Resultant direction must be in that direction, because if it is, so that's mean when plane actually in the runway, the surface provide a force in the opposite direction. If the frictional force is not going to be enough to stop the plane in the horizontal direction, then the plane definitely is going to be skid from the runway. But we don't want that. We want the safe landing of the plane, right? The vertical direction is right, which is actually the descending the height of that one. For the safe landing, definitely the force would be in that negative x direction. In that case, the resultant force must be in the third quadrant. Now we'll verify that one using that one. Look at this. I will just expand the vector is given over here, and then I will split that vector. I'll find out that component. Let's try to draw. So I will represent that vector over here. Say one vector would be towards that direction, which is basically the F2. This is actually the F1. I extended that part, which is actually that F4. And this is actually your F3. I level that vector in that way. You can do that without, I just shift that origin of that vector without changing the direction. So this is my positive x and positive y. I can label. So this is actually that F1 vector. This is actually your F2 vector. This is actually your F3 vector, which create the angle of 45 with that axis. And this is actually that F4, which they create the angle. I should say this is would be the 30 degree over here with that. So 30 degree. Right? If you extend that part actually of that vector, then definitely this one would be 30, because that angle is 30, that angle will be 30. So that's why it's creating angle 30 degree with that positive y-axis. Now what would be my job? My job would be basically I have to represent that vector in a component. F1 I can write, it will be minus F1 into j hat, right? I can write that one in a vector form I'm representing in terms of unit vector. I know the magnitude of F1. I'll just plug in over there. So what would be that F2? F2 would be minus F2 I hat, because it is towards the negative x direction. That's fine. Now what about that F3? F3 would be F3 cos 45. I hat is create an angle with the positive x-axis 45 degree minus F3 sine 45 z hat. Do you understand this thing, the split of that vector or the component of that vector I write in that way? Is that okay for you? Do you understand this equation? Whatever I write in for the F3?
Yes, sir.
That's good. If you understand, then
Yes,
your
sir.
problem is going to solve. This is very important. This is very important component of this vector. And what about the f4? F4, I'll write minus f4 cos 60 degree I hat plus f4 sine 60 degree z hat, because that angle is 30, and definitely this is going to be the 60 degree. That means that f4 create 60 degree with the negative x-axis, so that's why I write down the minus sign over there, and it's create that with the positive y-axis, actually that sine 60 degree I write in that. Then you can find out the value of this thing, because you know all the value of f1, f2, and the f3. If you plug in over there, you will find out the value of this thing. Now, what would be my resultant force? Resultant force would be basically sum of this f1 plus f2 plus f3 plus f4. If I add them all together, just plug in the number over here. I hope you can do that. If you do that, you will find out this answer will be 1.65 into 10 to the 3 I hat minus 6.2 into 10 to the 2 z hat. So this is will be actually that resultant vector. And you look at this, the component, both two component actually the negative. Your x component is negative and y component is also the negative, then definitely the vector would be in the third quadrant. And you can also find out the magnitude and the direction. But when you find out the direction would be basically, if you use your calculator, that is going to be give you, let me check that, what would be that one. It would be 6.2 into 10 to the 2 divide 1.65 into 10 to the 3. It's a 0.375 inverse, tan inverse. It's going to be the 20 degrees. So 20 degree, that's mean from your this angle is would be the 20 degree, but you have to count down from the positive x. So that's mean you have to add this 180 degree also. You can find out. So then FR, if you say the magnitude of that, let me check that one. It's a 20.5, that is going to be 1.65 into 10 to the 3 square. I hope you can do that, right? 6.21 into 10 to the 2 square is going to be 1.73 into 10 to the 3 Newton, and the angle would be basically 20.59 plus 180 degree. It means 200.59 degree. That should be the answer of this one. That's why the resultant vector will be in the third quadrant. So that's how actually you can find out the magnitude and the direction using that vector component.
Sir, I have a question.
Sure.
Sir, in the need force Fk, why didn't we add F3 and F4?
Mid question means I didn't get
Sir,
your question.
Fk is equal to F1 plus F2, F3 and F4. Okay.
F FR, yeah, resultant
So
force. Some,
Fr, yes,
yeah.
sir.
Mhm.
So did you add all the four units?
Yeah, definitely, because four forces is acting over there. If I want to find out the resultant vector, I have to add all of them.
Okay, sir.
If you want to find out the resultant, definitely you have to add all of them. Probably you are talking about why we add four at a time, right? Is that your
Ye-
question?
yes, sir.
So if you want to do in step by step, first add 1 and 2, then with respect to that with 3, and with respect to that in 4. That should be the tedious method actually, if you want to do in that way step by step. But I can add them all together at a time. It's a basically addition and the subtraction.
Oh, okay, sir. I understand.
All right, is there any more question?
Sir, I have a question, sir.
Sure.
Sir, on F3, we're writing that F3 cos 45 I hat minus F3 sin 45 J hat. So
Mhm.
we are using the minus sign because of the fourth quadrant, sir.
Yes, your y component must be in the downward direction.
Okay, sir. I understand. Thank you, sir.
because if you speed, that's why we talk about the graphically. Unless you cannot predict that one, there will be a confusion why I write them that way. If you can visualize that vector, oh, it is in the fourth quadrant, definitely one component. Look at this. If is want to be my resultant vector in the term of, then I have to split one vector in that direction. Sorry, then couldn't be that one. It would be, say, one vector would be towards that direction, another vector would be towards that direction. Then I will find out this resultant vector, right? If you use the idea of the uh, vector triangle law, and it is actually it is. It's all depend on this vector triangle law. If you understand the vector triangle law properly, then you can understand this thing very easily. The component, blah blah blah, everything comes from this vector triangle law. Addition, subtraction, all of these things come from this vector triangle law. That's why this x component is positive, I use the plus sign, but this is actually the y component, which is downward, I give you the minus sign over there.
Yes, sir, I understand.
All right, is there any more question?
No,
No,
sir.
sir.
That's great. The end of this class. And remember, probably the next Wednesday will be probably the holiday, the Miladun Nabi. There will
Yes,
be no
sir.
live session in that case. See you in the next
Sir, I
week.
have a
When
Sir,
you,
question.
Sir,
yeah,
when will be published the week two?
did you
sir, when
completed
will week 2 be published?
week two?
Yes, sir.
Did you completed week one all the portion? The problem
Yes,
solved,
sir.
problem
Question,
number given from the reasoning calendar worker.
no, sir. We have only
Then
completed the
then
index.
you are not doing. You are not completing the first week properly. You are asking for the second week. Why? First, do your job properly.
We just
If
want to
you,
see the topics, sir.
sorry,
Sir, if we see the topics, then we will get a general idea. That's why I asked the question.
I know that one, but still you have a problem with the week one. You didn't complete the problem number we provided from the reference book. Do that first one. If you have success, or if you can do that one, then you can go for the next step. Without doing the first step, you are thinking of the second step, which is should be the meaningless actually. If you have a
Sir,
problem over here with the vector, it will be difficult to follow the second week or the third week. So that's why I'm telling you, please guys, do your job properly.
sir, are we going to have to do any assignments this week?
Probably not. They will deploy assignment in the next week. Assignment and one graded quiz is coming for you. Probably the graded quiz will be next week, next Thursday. We are thinking about to take a graded quiz in the next Thursday.
So on two
Sir,
weeks.
is it on vector or
Yeah,
any other
probably.
topic?
No, it would be probably the vector and little bit also for that second week. The first lecture, probably they will going to cover the first graded quiz.
Sir, I have a question, sir.
Yeah, sure.
Are we gonna face the questions like today, the plain one? I mean,
Of course.
this type of
Then,
questions will appear.
of course. Then why I'm doing this thing is for fun.
No, no, sir.
Then this is the application. Look at these guys. You know the vector. You can add, subtract, multiplication starting from your school life, but you can apply. You cannot apply this thing in your real life. Did I do anything hard over here? Say,
No, sir.
No, sir.
I just tried to
No,
show you
sir.
the I just tried to show the application of this thing. I didn't do anything new for you, right? I represent in a different perspectives. Look, you know this thing, but you cannot apply this thing in your real life. That's a big problem. That's a very big problem for our science community. We are preparing skillful person. We are expecting that they will be skillful, but that you cannot apply this thing in our real life. Then what is the purpose of engineering? How do we define the engineering? If you cannot apply your science in your real life, then you are not going to be engineer, skillful engineer.
Yes, sir.
Yeah, it should be that way actually. Think about it in that. All right, so you can guys, if you don't have any question, you can leave.
Okay, sir. Assalamu
Yeah,
alaikum.
Allah Hafiz, sir. Assalamu alaikum.
Allah Hafiz, sir.
Assalam.